All right, welcome. Today's an exciting day. We get to do the definition of the derivative. Now remember that we've seen that if s was the position function as a function of time, then the velocity at some time a was just the limit as h went to 0 of s at a plus h minus s at a all over h. We also saw that if you take any old function and you look at its graph, then the slope of the tangent line at x equals to a was the limit as h goes to 0 of f of a plus h minus f of a all over h. And so, look at it. These are the same constructions. So this procedure actually comes up in lots of different scenarios. And because of that, it gets its own name. It's going to be called taking the derivative of a function. All right, so definition. For a function f, the derivative of the function f at x equals to a is, now it has a number of different notations. Let me give you one of the main ones and then we'll come back and give some others. It's written f prime at a, and it's defined to be the limit as h goes to 0, f of a plus h minus f of a all over h. Some alternate notation. People also write it this way. They write df dx at a. They also write df dx evaluated at x equals to a, for instance. And then they also write it like this, d by dx of f at a. Okay, so lots of different notations. We tend to use this f prime a lot and the df dx. Physics people especially like the df dx. It kind of makes sense for a lot of physical reasons. All right, so remember, derivative is limit as h goes to 0, f of a plus h minus f of a all over h. There's an alternate way to write it. So alternate version. And all we're doing in this is we're setting b to be a plus h. So h going to 0 is the same thing as, well, if h is going to 0 here, then b is going to a. So these are the same condition. And so if you just go back here, this a plus h will be changed into a b, and instead of saying h goes to 0, you'll say b is going to a. So you can also write it this way. F prime at a is the limit as b goes to a, f of b minus f of a all over b minus a, because if you check here, that's the same as saying h is b minus a. All right? So you can do it that way as well. It just depends what you're wanting, sort of the scenario. For most of our initial examples, we'll be doing it with this first version. They give the same answer, of course. Now, one thing to notice, that the derivative is calculating something we already know. If f is the position of something, then you can interpret f prime as the velocity. Okay? And you can also interpret f prime at a as the slope of the tangent line to the function f at x equals to a. Okay? Because that's what it was. All right, we'll do some more examples soon. Ciao.